So when hydrolysis occurs, carbonic acid wants to combine with hydrogen ions. Hydrolysis also happens in steps. First, I grab a hydrogen from water to form hydrogen carbonate. Okay, so this is called KH1 and this is called KH2. It becomes hydrogen carbonate when I grab another hydrogen from water. Of course, the first step of ionization is the main one. In hydrolysis, the first step is also the main one. Pay attention to which is the first step and which is the second ionization shouldn't be a problem, but with hydrolysis, be careful. This is called the first step of hydrolysis, carbonic acid. Grabbing hydrogen to form hydrogen carbonate is the first step. Then hydrogen carbonate combines with hydrogen. You already have one hydrogen. When you combine with another hydrogen, that's second step hydrolysis. Now we need to study what properties hydrogen carbonate solution shows. For example, sodium bicarbonate. We've learned the conclusion. Sodium bicarbonate is basic. That's what you should remember. We need to study how to determine the acidity of all acid salts. Let's see what properties hydrogen carbonate shows in solution. We look at what behavior it exhibits in solution, what reactions occur. Hydrogen carbonate will ionize. At the same time, hydrogen carbonate will also hydrolyze. So you need to focus on the second ionization step, K2 and KH2. See if ionization produces hydrogen ion, solution shows acidity, but it also hydrolyzes simultaneously. Hydrolysis produces hydroxide ions showing basicity. So is it acidic or basic in the end? You have to determine that. You must see if ionization or hydrolysis is stronger. And for this problem, you need to be more precise about which step of ionization and which step of hydrolysis. This is its second step of ionization. It's the second ionization of carbonic acid. Hydrogen carbonate continues to ionize. This is the second hydrolysis of carbonate. Now it undergoes first step hydrolysis. The hydrogen carbonate then hydrolyzes. So we can make an overall conclusion here. When K2 is greater than KH2, it's simply put, ionization is greater than hydrolysis, electricity greater than water. That's it. Meaning you produce more hydrogen ions than hydroxide. Because your equilibrium constant represents the degree of forward reaction, larger K2 means more hydrogen ions are produced, and hydrolysis produces fewer hydroxide ions. When ionization exceeds hydrolysis, H plus exceeds OH, so the solution is acidic. Of course, the opposite isn't true. I want to directly explain. Okay, this is an important method for determining the acidity or alkalinity of salts. It's about judging the relationship between ionization and hydrolysis of acid salts. Because for acid salts, for example, let me use another one. We actually have many acid salts that we can summarize in advance. For instance, known acid salts where ionization exceeds hydrolysis include what? There's hydrogen sulfate, right? It can ionize to release a hydrogen ion, and it can combine with a hydrogen ion in water to form sulfurous acid. Both ionization and hydrolysis occur, so ionization must exceed hydrolysis. We can note this as a helpful point to remember these common acid salts and their acidic properties. Besides this, what else? Hydrogen oxalate and dihydrogen phosphate. Good, so what about alkaline properties? The sodium bicarbonate we just mentioned is actually alkaline. Its hydrolysis is greater than ionization. Good, who else? Hydrogen sulfide with hydrogen sulfate ions. Good, who else? Monohydrogen phosphate. This is also a buffer system commonly used in our biological bodies, how to determine the acidity or alkalinity of an acid salt. We need to compare the behavior of the acid salt in solution. Since it can both ionize and hydrolyze in solution, ionization generally produces hydrogen ions, hydrolysis, hydrogen ions. So you need to compare the degree of ionization versus hydrolysis to determine if the solution is acidic or alkaline.